Now suppose the given differential equation is not exact, but I want to convert it to an exact differential equation. Then how do I do it? Let me take an example. Suppose there is a differential equation y dx minus x dy is equals to 0. So it is in the form of m dx plus n dy, okay, where the value of m is y and the value of n is minus x. Now del m by del y is equals to 1 and del n by del x is equals to minus 1 here. So you can clearly see both are not equal. That is, del m by del y is not equal to del n by del x. That means this differential equation is not exact. Now if I want to make this differential equation exact, what I will do is I will divide it by x square. That is, y dx minus x dy divided by x square is equals to 0. Now I can write it as minus of x dy minus y dx upon x square is equals to 0. What I have done is I have taken minus common here. Now this whole term can be written as minus derivative of y upon x is equals to 0. Why? Because if you take the derivative of y upon x, you will get the same result, okay? Now integrate both the sides, you will get y by x is equals to constant. If you integrate this term, you will get y by x, and if you integrate 0, you will get a constant. So this is the solution of the given differential equation. Otherwise, you can divide this differential equation by y square as well. That is, y dx minus x dy upon y square is equals to 0. Now this whole term can be written as derivative of x upon y is equals to 0. Now integrate both the sides, you will get x upon y is equals to constant. So this is the solution of the given differential equation. That means you will have to multiply it or divide it by a certain term in order to make it exact. But I can say I have multiplied it by 1 by x square or 1 by y square. So this term will be known as integrating factor. That is, by multiplying the equation with an integrating factor, I can convert a differential equation into an exact differential equation. As you can see, we have multiple options which we can multiply. Either you can multiply by 1 by x square, or you can multiply by 1 by y square, or even you can multiply it by 1 upon x square plus y square. That will convert it into d of tan inverse. That means the integrating factor for any equation is never unique. It can have different form. Now let us see certain cases where you can have certain standard